Hello everyone, welcome to our channel Simplified Computer Science Concepts by Professor Rutuja. Today we will be learning election algorithm in distributed systems. So let us begin. So in many distributed algorithm requires a process that acts as a coordinator. So the coordinator can be any process that organizes actions of other processes. So let us map this concept to a real-time concept wherein if you are living in a society has a chairman who will coordinate the activities such as paying the bills, arranging the meetings, likewise. Now, let us consider that this coordinator or a chairman is living abroad. Now, the post of chairman should be taken over by some other person. In the similar manner, if we map this concept to a distributed systems, a process is a coordinator, and if that particular process fails, then a new coordinator or a new process which will act as a coordinator must be elected. So here in many systems the coordinator is chosen by hand, for example file servers. But then when they are chosen by hand, that becomes a centralized approach and it becomes a central point of failure. That means if file server fails, then other related components will also fail. Now let us look at this example wherein these are the two partitions of the network and they are connected with a router. But then when this router itself got crashed, then the two networks are leaderless. So a leader or a coordinator must be elected. So how to elect a new coordinator or how to choose a new coordinator? So here the concept of election algorithm comes into the picture. So the assumptions are each process has a unique identification number to distinguish them, and process should know each other's unique ID, and the process with the highest priority will be elected as the coordinator, and if a failed process recovers, then it can join the set of active processes. So two election algorithms we will be learning, that is the Boole algorithm and the ring algorithm. So in Boole algorithm, a process P notices that the coordinator is no longer responding to the request. It initiates an election message. So what we will do is we will first go to the illustration and come back to the algorithm. So here process 5 sends a request to 8, which was the coordinator, but then it does not sends reply to 5 within a specified time limit, which means that 8 has got crashed. 5 understands that 8 has got crashed because it has not replied to him within a specified time. Let us say the specified time was 2 seconds and 8 has not replied to 5 within 2 seconds. So 5 understands that 8 has got crashed because it has not received any response. So it initiates a election message. So to whom it will send an election message? So to the processes which are higher in priority to that. So which are the processes higher than 5? That is 6, 7 and 8. So it will send an election message to 6, 7 and 8. 8 was already crashed. Now the processes with the higher priority than 5, that means 6 and 7, 8 was crashed. 6 and 7, if they are alive, send OK message. So here they are sending an OK message to the initiator of election message. So who was the initiator? That is 5. So they are sending the OK message saying that we are alive and we are having higher priority than you. So you can sit down or you can take rest. We will take care of other things now. Now what happens? 6 will send the election message to 7 and 8. 8 was crashed. 7 is the higher priority process than 6. So that is why it is sending election message to 7. Now 7 will reply saying that I am alive. You can take rest. I am okay and I will take over you. And 7 will now send message to 8. But 8 has got crashed. So the 7 is the highest priority process. So 7 now is elected as a coordinator and broadcasts coordinator message to all the processes in the network saying that I am the newly elected coordinator. So this is the Boole algorithm. So one of the demerits with the bully algorithm is that there are higher number of messages that are passing through the network. So there will be a lot of traffic congestion or heavy traffic in the network. And also one more demerit is that all the processors should know each other's unique IDs. So this was one of the demerits. Now looking back at the bully algorithm, just map this concept to our algorithm, wherein when a process P notices that the coordinator is no longer responding to the request, it initiates an election, which means that process 5, which is no longer getting response from 8, it initiates the election message. So 5 will send an election message to the processes with the higher number. If no one responds, that means if 6 and 7 will not respond, then 5 will send an will win the election and send the coordinator message to all the other processes. But then if 6 and 7 replies to 5 saying that we are higher than you and we will take over your job, then when a process gets an election message from one of its lower number processes, the receiver sends OK message back to the sender to indicate that he is alive and will take over. So here 6 and 7 sends an OK message to 5 saying that we are alive and we will take over. And the new coordinator announces its victory by sending all processes a coordinator message. So 7 sends a coordinator message to all the processes in the network saying that he is the new coordinator that is elected. And let's say if a process that was previously down comes back. So in our illustration, if 8 process which was earlier crashed, now it comes back. In that case, what will happen? It will held an election. So 8 will held an election, and if that process, that means here 8, if it is the highest process which is currently running, then it will win the election and it will be elected as a new coordinator. So the concept is the biggest guy always wins, and hence the bully algorithm. So the biggest guy is in our illustration it was 8 which was crashed, but then ultimately 7 was the highest process with the highest priority number, so 7 got elected as a coordinator. So thank you for watching this video. Please like, share and subscribe to the channel Simplified Computer Science Concepts of Professor Rutuja. Thank you for watching the video. If you have any queries, you can put into the comment box. Thank you for watching the video.